all the halogens, please highlight, all the halogens are strong oxidizing agents. But usually we only take chlorine and bromine because iodine is a bit weak. Okay, but the two famous halogens. All right, aqueous chlorine, I told you, it is greenish yellow, light green solution. All these are in solution form. Aqueous bromine, I told you, it's in orange. Yes, okay. So I'm bringing the previous worksheet into today's one. Understand, Satish? This was in the previous worksheet, so I'm just bringing it today. I put it in today's group, in today's one. Okay, so you don't have to use the previous one. All right, So aqueous chlorine, greenish yellow. Okay, it's light pale green solution. Aqueous bromine or bromine solution is orange in color. You can even put it brown also can, orange also can. All right. Iodine definitely is brown. Okay. So you have to know this. Okay. All these contain molecules. Aqueous chlorine, aqueous bromine, aqueous iodine all contain molecules. Okay. And then another very famous second bullet, another famous oxidizing agent is acidified potassium manganate 7. The one which is purple in color. Okay. And then there's another very famous, the last oxidizing agent, which is this is orange in color. So we call it as acidified potassium dichromate solution. So today we are going to take one oxidizing added to one reducing. All right. And then we see the color change. So the another thing you must know, the famous reducing agent. So oxidizing we have done. So what is a reducing agent? Okay. These are the three famous ones for SPM. It's Fe2+. Just put down here Ra. Reducing agent, short form. Okay. This is OA. All these are OA. Strong, Okay, chlorine, bromine, potassium manganate, and this one, this 4. This one is, first one is Fe2+. Okay, this is the first oxidizing agent. All right, Fe2+. Then the next one is, you can take as bromine, Br-. For your SPM syllabus, these are the only 3 they're going to give you. And the third one is iodide. So all our questions today involve these 3. We can use chloride ion, but chloride is not, usually don't ask because you can't see the color clearly. The color change also, all right? So Fe2+, you can see the color change. Okay, so make sure you know that. Okay, ready? Let's continue. Okay, so the first one is redox reaction involving change of iron 2 to iron 3. So you must know the observations, the half equations, all that you must know. Okay, so what we have here, okay, I want you to do some highlighting. See bromine water, all right, you're adding bromine water to iron 2 sulfate. So iron 2 sulfate here, the iron 2 is your reducing agent. Just note down here first. This one, the sulfate doesn't play a role. Okay, then your bromine water or your aqueous bromine, okay, is your oxidizing agent. Usually when you add the oxidizing agent to reducing, you must heat up to speed up the rate of reaction. Okay, so you can see the color change here. We'll discuss now. Ready? Okay, let's go for the first one. Let me clear first. All right, first one is bromine functions as oxidizing agent. Correct? I told you that. You just have to memorize the 3. All right, the 3 famous oxidizing agents. Okay, one of it is bromine, one of it is halogen, dichromate 6, manganate 7. Okay, so what is going to oxidize? Note that down first because it's oxidizing agent. It's going to oxidize iron 2 ions here to iron 3 ion. Right? I want to write in words. Iron 3 ion. Iron 2 ions oxidized to iron 3. By what? By bromine. Okay, as I told you, okay. Now you find that iron 2 ion is a reducing agent. So what is going to reduce? It's going to reduce bromine water or bromine to bromide ion, Br-. So check, Br2 become Br-. Right? It's standard SPM. So this is a reducing agent. That's why I use the word, it reduces bromine to bromide ion. Okay, get me here? All right. So this one done. Okay, let's go for the half equation. Okay, write down the half equation for oxidation. Fe2+ is becoming Fe3+. Can you write the half equation for me now? All right, I'll guide you quickly. All right, Fe2+. okay, becoming Fe3 plus because iron 2 plus is oxidized. Okay, reducing agent becomes oxidized, correct? Okay, let's write the half equation. So this one we have done it the other day also. Fe2 plus arrow Fe3 plus E. Is that correct? Okay, this is your half equation for oxidation. All right, reduction. Okay, Br2, remember, okay, bromine is your oxidizing agent, it will become reduced. Okay, reduction is for the oxidizing agent, it will become reduced. Huh? So obviously it's going to become, oh, wait, let me just erase, I need some space here. You need some space here, all right, and then you continue here, all right, you put an arrow there, Br2 become Br minus. I told you that there's 2 Br there, so you must put a 2 here to balance. Okay, Jain, give me an answer, Jain, for this. Reduction is, so what's the answer?
Br2 plus 2E arrow.
Well okay, never mind. Okay, Br2 plus 2E, well done. Okay, oxidation is loss of electron. The Fe2 plus loses 1 electron, so the minus E becomes plus E. Okay, now let's go for overall. Write the overall now. As I told you, when you write overall, okay, you have to get rid of the electrons. All right. Okay, sini tengok. There's 2E, here is E. So you want to get rid of electrons, you must make all the upper part multiply by 2. So you put 2E here, you multiply by 2, and then you multiply by 2. Can you see? Then you can see this is right side, this is left side. The 2E and 2E will cancel out. Correct, right? Okay? So now write the overall for me. You add up all on the left side, arrow, add up all on the right side. Okay. Alicia Ong, can you give me the overall ionic equation?
Br2 plus
Okay, Br2.
2 Fe2 plus.
All right, Br2 plus 2 Fe2 plus. Okay, then
arrow 2 Fe3 plus.
Is that all?
Plus 2 Br minus.
2 Br minus. So that is your overall ionic equation. Sometimes they'll ask you to write. Sometimes they just ask you to write only half equation. Okay. All right. So let's go for observation now. Okay. First observation. All right. Jiao, tell me the first observation for this. Okay. What's observation? Observation, go for color change. Fe2 plus becoming Fe3 plus. You don't observe that. You observe the color change. So put in words for me.
Pale green to brown.
Pale green. Okay. Oh, I think. Okay. Very good. Well done. All right, but you write down like this. You don't just say pale green to brown. What you do is
the solution in the test tube changes color from pale green to brown.
Okay, because the solution in the test tube is this one, isn't it? Okay, very good. So solution in the test tube, or you can just say iron 2 ions. All right, changes color. Sorry, the solution in the test tube. Sorry, the solution in test tube changes color from pale green to brown. Okay, first one. The first one is for this. Then what is the second observation? Okay, as you add the bromine water, all right, you can see immediately becomes colorless. So put down bromine water is decolorized, or bromine water becomes colorless. Or bromine water changes color from orange or brown to colorless. Also can. Decolorize also boleh, changes color. Okay, and then state the oxidizing agent here. Okay, Elisa Lee, are you here today? Elisa Lee? Okay, you tell me what is my oxidizing and reducing agent. Give me the answer.
Wait. The oxidizing agent is bromine water.
Okay, bromine water. Okay, bromine water equals bromine. Well done, Okay, reducing agent? I want in. What's the reducing agent?
Iron 2 sulfate.
Iron 2 sulfate or iron 2 ions also can. Okay, iron 2 ions or iron 2 sulfate. Both also accepted. Actually, it must be, it's better you put Fe2 plus. You know why? Reducing agent becomes oxidized. Correct or not? So it's actually Fe2 plus only. Iron 2 ions will be better. Just put iron 2 ions. Because iron 2 ions becomes iron 3 ions. See, the rule is this. Reducing agent becomes oxidized. Oxidizing agent becomes reduced. So this is reducing agent becomes oxidized. Can you see? There's no sulfate here. So don't try not to use the word sulfate there. Just iron to ion. Here, reducing agent only this one. So aqueous bromine or bromine becomes reduced. So the oxidizing agent is bromine. The reducing agent here is Fe2+. Because why? Oxidizing agent becomes reduced. Reducing agent becomes oxidized. Okay, yeah? All right. Well done, Lisa. All right. We go to the next one. Make sure you know all this. All this is going to be used in the later lessons. Huh? Okay, that's right. Second one. Okay. All right. So now what I'm going to do, I put like a dropper there. Aqueous bromine is here, and then potassium iodide is here. So you're adding a few drops. Okay. All right. Again, as I told you, any diagram there, you write down which is your oxidizing agent and which reducing. So this one is your oxidizing agent. Put OA there.
Teacher,
Yes.
can I ask a question about the first one? The first question.
Sure.
The observation, right? You say that the solution in the test tube changes color from pale green to brown, and then bromine water is decolorized.
Yes.
Because you mix those two colored solutions together, how do you know if bromine water is decolorized? Because the overall.
Okay. I will show you a video in the next lesson. But you see what happened. Okay. The video will be very clear, you know. You see, Okay. To answer your question, you see, when the bromine water is coming here, the moment it comes and touches it comes in contact with the solution, you can see it changes color. Whatever oxidizing agent, whether it's potassium manganate 7 or bromine water or dichromate 6, you know. Okay. The moment it comes in contact, it will become decolorized. So that's the first thing, the bromine water becomes decolorized. You can see that very clearly. I'll show you the video. Okay, next lesson. And then here the oxidizing agent will the reducing agent will slowly start to change color. You can see the oxidizing, the agent becoming decolorized at the tip here. All right? Whereas the reducing agent will change color, you can see somewhere here. That will answer your question. You understand? And when you see the video, next lesson, you will be very, very clear. Okay? All right? We continue, Okay, so let's go for this. Okay, so again, you put down OA here. This is oxidizing agent. This is your iodide. Now, your iodide is your reducing agent, not potassium iodide. Okay, so you underline there and put down here. This is what you underline. That is your reducing agent. Okay, and then one more thing, if you can, you write down the color here. Okay, this one you put down brown or orange. Okay, all right, and then this one you put down. This is colorless, all the iodide, bromide, chloride, all colorless. So write down colorless. COLOURLESS. Okay, write it down, Okay, now you answer the question. Okay, now try. Can I clear? Oxidizing agent, reducing agent, color. Okay? So now we clear. Now we go here. Okay. So again, this is oxidizing agent. The bromine water or aqueous bromine functions oxidizing agent. What does it do? Okay, who wants to try? Satish, tell me. What does it oxidize?
Bromine water oxidizes iodide ion to form iodine molecule.
Okay, it oxidizes iodide ions. Write down in words, iodide ion, IODID. Iodide ions to become iodine. All right. Iodide ion is colorless. So you can see when you add, you can see there's a color change here. From colorless to iodine becomes brown. That's the first thing you observe. And then the second thing, when the bromine water comes in contact here, it becomes bromide ion. So it becomes colorless here at the surface. Okay, at the same time, iodide ion is your reducing agent. Correct or not? So it will what? Put on. It will reduce. Because this one oxidized, this one will reduce. I minus. Iodide ion is I minus. Okay, maybe I just put the charge a bit further. Okay, iodide ions will reduce bromine to become bromide ions. Bromine is oxidizing agent, it becomes reduced to become bromide ion, Br minus. Okay, that's why you put in words. Okay, let's go for half equation now. Okay, write down first. Oxidation now, I minus, okay, I'll guide you. I minus, all right, correct. It's your reducing agent, it's going to be oxidized, becomes I2. Okay, you complete this for me. At the same time, your Br2, this one you did just now, itu sama saja, Br2 becomes Br minus. Okay, complete this for me with your equation, with the electron, sorry. Okay, do it. Notice something, here is I2, so you must put a 2 there. Now, this is or -2 to 0 lah, or -1. Okay, -2 to 0 is oxidation. Alright, -1 is okay. You take the original one, -1 to 0. There's no charge. Okay, going the right. Oxidation is loss of electron. So there's 2I here, so you must put 2E there. Is that correct? This is your half equation for oxidation. Reduction just now, Jayin gave the answer. This Br2 plus 2E. Okay, what is the overall? You notice now the 2E here, 2E left side, 2E right side, to add up everything. Okay. Jaden, give me the answer, Jaden. Overall, I need equation. Quickly.
2I.
The sequence doesn't matter. You can mention Br first, Br2 first, or I minus first, doesn't matter. Okay? Okay. Give me the
2I
answer.
minus 2I minus plus Br2.
2I minus plus Br2. Okay, so you notice something? The 2E and 2E will cancel out. Huh? Okay. Arrow, continue.
Arrow I2 plus 2Br minus.
This is, sorry, this is 2Br minus. Huh? Okay. Forget about that. Okay. Well done. Huh? Very good. Br2 become Br minus, but I put a 2 there to balance. 2Br, Br2. Make sure you know this. This one is the last. Okay. Then go for your observation. Okay. What's your first observation? Jia, tell me, Jia. What's your first observation? Let me clear first. Wait, let me clear first, then you can see it clearly. Okay, I clear first. What's your first observation?
The solution in the test tube will become colorless to brown.
Okay, so you say solution in the test tube. Okay, write down observation number 1. Solution in test tube.
Colorless to brown.
Colorless to brown. Always mention color change. Well done, Jia. Solution in the test tube changes color from colorless to brown. Okay, that's the first observation. And then what happens to oxidizing agent when it at the surface here? Continue, Jia.
Bromine water changes from brown to colorless.
Okay, or aqueous bromine also can. Bromine water changes color from brown to colorless.
Yeah.
Okay, so, well done, huh? Okay, and then let me see. Which is your oxidizing agent? Which is oxidizing agent? Bromine water, or aqueous bromine. Reducing agent, please note down, you just put iodide ion, because reducing agent becomes oxidized. It's the I minus becoming I2. It's not the potassium, so don't go in potassium iodide. Okay, so reducing agent is iodide ions. Okay, settle, huh? Alright, you're going to do this now for me now. Okay, we try one more. Okay, now I change my oxidizing agent. Instead of putting bromine, I'm going to use acidified potassium manganate 7. Okay, you complete for me now. Same thing again, alright? I told you the same thing. What you do? You write down which is your OA and which is your RA. Okay, so here this is your oxidizing agent. Kalau boleh, write down the color. This is purple. Alright? This is purple in color. Okay, this is your reducing agent. You underline the iodide ions, put colorless. Okay, it is colorless. And then you write that down. It will be your reducing agent. Okay, shoot. Right now? Okay, this one is a special one. I told you, kalau boleh, I told you to memorize it. Okay, we try this first. Acidified potassium manganate 7 solution functions as an oxidizing agent. Correct, isn't it? Okay. So if it's oxidizing agent, what it will do? It will oxidize what? Okay. Who wants to try? Yongsin, want to try? Part B? Yongsin?
Yes.
Okay, try. Part B. What will it do? It will oxidize what?
Oxidize iodide ion
Yes.
to iodine.
Okay, well done. It will oxidize iodide ion to iodine. You must mention the word very iodide ion to iodine, iodine or iodine molecules. At the same time, okay, who wants to try now? Sandra? Try C.
Iodide ion reduces
Reduces. Okay.
potassium dichromate 6 to
My
become
little dichromate 6, there's manganate 7.
7
Okay.
to become potassium dichromate 6.
Okay. Not very accurate. See what happens, I told you the other day, MnO4 minus will become Mn2 plus. Okay, that is what is actually happening. You see, the reducing agent is this one, you see, MnO4 minus. This is oxidizing agent. So it becomes this, that's all. So how you put it in words now? So how you put it in words? All right, I just want you to explain this one only. Okay, because this is where the reduction taking place. This is plus 7, this is plus 2, remember? Okay, this is where the change taking place. Okay, send me. All right, we try it now. Let me guide you. Iodide ion, put a word reduces. All right, your oxidizing agent here is your MnO4 minus. So reduces manganate 7 ion. Right on. MANGANAT, which is manganate 7 is this one. All right, MnO4 minus. Okay, reduces manganate 7 ion to manganese. Write down. MANGANESE. Manganese. Put Roman numerals 2 ion. You have to know this, important. Write it again, Iodide ion. All right. This oxidizes, this will reduce. Manganate 7, MANGANAT. Roman numeral, put 7 ion. To become manganese, MANGANES, manganese 2 ion. Okay. Now let's go for the oxidation. I minus. Okay, I minus. All right, is becoming I2. Okay, you complete this for me now. So first balance, I2, so you must put a 2 there, 2I minus. Okay, 2I minus. So this is negative 1 to 0. It's oxidation, so it's 2I minus, so you must put plus 2E. Okay, this one is no problem. Okay, then this one I told you, when it involves MnO4 minus, all right, it's acidified. Okay, so there's a special half equation. Chu, did I show you how to change this to Mn2 plus half equation, the reduction? Did I do it with you, Chu, the previous lesson?
I think we did.
We did that, okay. I told you to memorize.
The calculation part, but then in details, I don't think so.
No. What I mean is the half equation. Did I teach you how to write the half equation?
That one, macam don't have that.
Satish, did we do that, Satish? Here in this class, in our school class?
No, not yet, sir.
We didn't do, Okay, I'm going to show you how you do it, Okay. So, all right. So what are you going to do? Okay, this one no problem, Okay, I just do it again. I minus becoming I2, Okay. All right. Listen carefully, All right. You put plus 2 equal. This one no problem, isn't it? Okay. The problem comes when it is acidified potassium manganate or dichromate. Okay, I'm going to show you, All right. So what you're going to do is this. Okay. The potassium manganate 7, the potassium doesn't play a role. It's only the manganate 7. So, okay, I'll do it here first with you, MnO4 minus. Okay, all right. Then, listen carefully, because this one they'll ask you to write an exam. Okay, plus, you see the word acidified. I mean, acidify means it contains hydrogen ions. So, it is H plus. Can you follow me? All right. You leave some space here. All right. And then you're going to put it. I told you it becomes pink to colorless, isn't it? Or purple to colorless, sorry. Purple to colorless. So it becomes Mn2 plus. Okay. It becomes this, All right. This is purple. This is colorless. Okay. And then, of course, the equation not balanced. H plus O is what? It's not O. It becomes what? H2O. Okay. So we do like this first. Can you follow me, All right, you write that down first. Okay. Once you have written, so let's check first. Mn, Mn. Okay? There's O here, but it's not balanced. So let's balance it first. Okay, Mn, no problem. Charge, tunggu dulu. How many oxygen here? 4 oxygen. So I'm going to put a 4 here. I'm going to use another color. I'm going to put a 4 here. Can you see that? 4 oxygen. 4 oxygen, 4 oxygen. How many hydrogen here? 4 times 2 is 8 hydrogen. So I'm going to put a 8 here. So you see all the atoms should are balanced. Mn, Mn. 4 oxygen, 4 oxygen. 8 hydrogen, 8 hydrogen. Okay. Next, we balance the charges. The charge on the left and the right must be balanced. So we're going to write the half equation. As you know, this one is Mn. I told you the other day, isn't it? Mn here is plus 7. That will be worked out. And this is plus 2. So you can see from plus 7 to plus 2 is reduction. Right? Okay, so reduction is gain. So you're going to put here gain. Gain means you're going to put plus. Plus how many E? That's a problem. So let's work out the total charge. Okay, I'm going to padam this one. I'll remove this and I'll remove this. Okay, let's try it now. Ready? Okay, what is the total charge here? MnO4 minus, so it's negative 1. Is that correct? Plus. Okay, what's the total charge here? Here is plus 1 times 8, so it's plus 8. Can you follow me? So the total charge here becomes minus 1 plus 8 is plus 7. Get me here? Alright, plus 7 here. So then the arrow is here. What is the total charge on the right side? Here you can see this is 2 plus, so it's plus 2. Here there's no charge because it's neutral. Water is neutral. Okay, so you see from plus 7 to plus 2. Plus 7 to plus 2, we know we are going backwards. Backward means reduction. So reduction, you are going to gain. How many electrons to change from 7 to 2? So you must put plus 5b. Okay, so in your SPM, all right, so I'm going to, you have to either memorize this, okay, in the SPM, you have to either memorize this one or you can derive it. When you go for A levels, let me tell you clearly, A levels, SPM, STPM or matriculation, whatever, there are other half equations coming in. You have to derive. So try not to. Now SPM only 2 saja, you have to know. This one manganate 7 and dichromate 6. If you can memorize, memorize it. If not, you can just derive it. This is how you get it. MnO4 minus plus 8H plus 5B. This is reduction, alright, because it's gain of electron. Becomes Mn2 plus 4H2. Manganate 7 ion is reduced to manganese 2 ion. So can you write the half equation here? Write it down now. MnO4 minus. Can you write it down first quickly? And then get the overall for me. That's a Lazada. What's that? Just answer the question first. Write the half equation now, please. Okay, let's try it now. Mn, so you write it here. MnO4 minus, as I told you, if you can memorize it, memorize it. It plus 8H plus 5B. Okay, and then this becomes Mn2 plus 4H2. Okay, all balanced. Okay, now there's one problem. Sometimes they also write the overall. Means overall you must get rid of the electrons. Okay, here got 2E and here got 5E. How to get rid of electrons? So that means the first part, upper part, you multiply all by 5. The lower part, multiply all by 2. So the 10E and 10E will cancel out. Okay, do it now. And then add up the left side and add up the right side. And give me the answer. Okay. Can you do it now, please? Is Sean here today? Sean is here. Sean is here. Sean. No, Sean can. Sean is here, but no microphone. All right. Let me see first. Okay. Who shall I ask? Okay, Yi Cheng, give me the final answer. Done already, na?
Haven't.
Okay, try this. So this one slightly bit more difficult because it involves MnO4 minus. So upper one all multiply by 5. Correct? Okay, we're going to do that now. Okay, I'm going to
Okay.
put. Okay. So here you multiply by 5 means this becomes 10I minus. Is that correct?
Yeah.
5I2 and then this becomes 10E. Is that correct? Okay. Then here, lower one, I use another color, all multiply by 2. So 2 here. So this one becomes 16, correct? This 10E. Okay. And then here it is multiplied by, okay, this is 2Mn2 plus and then this is 8H2O. Is that correct, Jeng? Okay, give me your answer.
2MnO4 negative
Okay, 2Mn4 minus
plus 10I
okay,
minus
10I minus, then?
arrow.
No, you forgot something. There's one more here. You forgot here.
Or plus 16H.
16H wrong again. 16H plus.
H plus.
Okay, I repeat again. 2MnO4 minus plus 16H. The sequence doesn't matter. Which one can come? 2MnO4 minus plus 16H plus 10I minus. Is that correct? Okay, then there's arrow there. Okay, continue.
Plus 5I2
5I2
plus 2Mn2 plus
2Mn2 plus
8H2O.
So the 10E and 10E will cancel. Okay, well done. You have, so please memorize this. Please, when it involves potassium manganate 7, it will be reduced. So please memorize that. After this, we're going to do for dichromate. Okay, all right. So the one done. So can I? Okay, have you copied already quickly? All right. So I need the space. Okay, clear this. Done. Okay, observation. Okay, so what happens here? So observation here, put down. You can even just put it as the acidified potassium manganate 7 solution changes color from purple to colorless. Write the word there. Okay, acidified potassium. I gave you 2 lines there. Acidified potassium manganate 7 solution. Write on first. Acidified. What you see? Potassium manganate 7 solution. Jangan lupa the manganate 7. Changes color from purple to colorless. Changes color from purple to colorless. So you can see when you do the experiment. All right, I'll show the video. You can see the moment it comes in contact here only, it changes color. It becomes decolorized. Okay, then we have iodide ion. Okay, that one no problem. Okay, you can even say solution in the test tube. Or you can just say, okay, the potassium iodide solution also can changes color from colorless to brown because iodide becomes iodine. Changes color from colorless to brown. Okay? And then which is my oxidizing agent? That one no problem. Oxidizing agent you put down. Alright, manganate 7 ion. Or you can even say acidified manganate 7 ion. Also. You can say manganate 7 ion we accept. Roman numeral 7, VII. Okay. Reducing agent, that one no problem. Iodide ions. Reducing agent here will be iodide ion. Okay, settle with that. Now we go to the next one. Okay, now is another oxidizing agent, the last one. All right, we'll try this. Okay, we have done bromine. All right, we have done using potassium manganate 7, now dichromate 6. Okay, say first thing, rule number 1. Same thing again, this is your oxidizing agent, put your OA. Okay, what is the color? Orange. All right, the color here is orange. Don't follow the color here. This one I just took as a template only. You must know the colors. Okay. Anyway, it's orange here. Okay, iodide ion is colorless. Okay, this is your reducing agent. Put that down first. Reducing agent, and then this is colorless. Okay, so that one you've done already, huh? Okay, so now we are going to, okay, I clear my drawing. All right, let's discuss this first, huh? Okay, acidified potassium dichromate 6 solution. This is orange in color, you know this one, huh? Functions as an oxidizing agent. You can highlight that one, huh? It is an oxidizing agent. I gave you the first info study. Okay, so if it's oxidizing, it will oxidize what? Okay, same thing again, write that down. Iodide ions to become iodine. It will oxidize iodide ions to become iodine. Okay, got that, huh? All right, oxidizes iodide ions become iodine. Okay, then this one. Okay, this is a reducing agent. So put down reduces. All right. Okay, reduces what? All right, you can use the word. It reduces dichromate 6 ions. Write this word here. Dichromate 6 ions. Potassium doesn't play a role. It will reduce dichromate 6 ions to become Cr3 plus. So you put chromium, CHROMIUM, Roman numerals 3. You have to remember this. Because Cr2O7 will become Cr3 plus. So it will reduce dichromate 6 ions. Don't forget the Roman numeral to become chromium 3, Roman numeral 3 ion, which is Cr3 plus. Because you must mention chromium 3. The chromium got plus 3, got plus 6, and plus 7 and all that. You understand? So don't just say chromium ion. Cr3 plus becomes chromium 3 ion. Okay. First one, oxidation, no problem. I minus becoming I2. Okay, write that on first. Half equation. The second one, I'm going to do with you. Reduction. Okay, we do it now. All right. Here, I minus. Okay, I minus is becoming I2. Correct? Iodide ion oxidized to I2. So you put I2 here and you put a 2 there. Correct or not? Okay, so this is oxidation. All right, so plus 2E. Okay, no problem, huh? Okay, only this one got problem. Okay, dichromate 6 and see the word acidified. Okay, shall we? So I'm going to do it here, empty space again, like what I did just now, huh? Okay, I'm going to use another color. So dichromate 6 is Cr2O7 2 minus. Okay, the potassium will cancel out, so don't bother potassium. See the word potassium? Don't bother. Okay, dichromate 6, huh? Acidified. Can you see acidified? So I'm going to put plus H plus. Need some space here, huh? Okay. Then need some space here to this arrow. Okay. Becomes chromium 3. So it becomes Cr3 plus. Cr3 plus. Okay, that one first. And then H plus O becomes H2O. Betul tak? Okay. H plus O becomes H2O. We got this one. Okay, so like what we did just now for MnO4 minus, all right, you're going to get the half equation. So this is the second one. You can either memorize this one or derive it. Okay, you have two choices, huh? Okay, they only give this two only, all right, where it's a bit more difficult to do, huh? Okay, let's try it now first. I pakai different color, huh? Okay, I use orange now. Okay. This one is orange in color, dichromate 6. Huh? Okay, you can see here. Cr2. So you must balance it. You put a 2 in front here first. 2Cr. 2Cr, Cr2. We balance all the atom dulu. Sini berapa atom? O7. 7 oxygen. So I'm going to put a 7 here. 7O. Can you see? Then 7 times 2 is 14. So I'm going to put a 14 here. 14. Can you follow me? I letak 14. So all the atoms on the left side, right side balance. Can you check, double check again? Cr2, 2Cr. O7, 7O. 7 times 2 is 14H, 14H. Okay, then lepas tu, we will balance the charge. Okay, what is the total charge here? This whole thing is negative 2, correct? Okay, but here you must be careful. Plus, this is plus 1, there's 14 of this. Can you see now? So it's plus 14. Can you follow me? Arrow here. Here, what's the total charge? 2 of this, so 2 times 3 is plus 6. This one, nothing there. Bam. So you can see minus 2 plus 14 is plus 12. Can you follow me? Minus 2 plus 14 is plus 12. Plus 12 becoming plus 6. Can you see now? 12 to 6, you're going backward. So it's reduction. So reduction is gain. So you're going to put gain. How many electrons? 12 to 6. So obviously must be 6e. So what you have to hafal is this one only here. Alright? The one I put in green. This is the one that you have to memorize. Only 2 one. Then how was MnO4 minus plus 8H plus, okay, plus 5e. Get Mn2 plus 4H2. So this is the second. So you write it here now. Okay, take the Cr2O7 plus 14H plus 6E. Okay, we write it now. All right, Cr2, and then you give me the overall. Cr2O7, capital C, this is capital C, 2 minus, okay, plus 14H plus 6E, ingat ini ya, plus 6E, arrow becomes 2Cr3 plus 7H2O, okay. You are going to get rid of the electrons, check and see first. Here got 2E, here got 6E. So what is a common number? 6. So the top one all multiply by 3. The bottom one tabaya. And then you add up. Okay, give me the answer. I need somebody to give me the answer. Work it out. I want the overall ionic equation. Write it down, please. This is another one more. Because they can take any oxidizing with any reducing. Okay, let me check. Who's around? Okay. Alfred, you want to try, Alfred? Or Avril? Okay, Avril, you try. Or Avril, okay, Avril, you give me the final answer, Avril. When you add up all the and you cancel 2E, the 6E and 6E. Have you done already, Alfred? Sorry, Avril?
Yes.
Okay. Are all of you ready? Okay, just hold on, Avril. You just give them another 1 more minute. Okay. Avril will give you the answer and you check. Okay, so you can see here, you multiply this by 3, okay, make it 6, so it will become 6E, so 3, and then this is 6I minus, so okay, Avril, okay, give me the answer, Avril.
6I minus
6I minus
plus Cr2O7.
Don't forget the 2 minus there, the charge for Cr2O7 must be there, Okay, repeat again. 6I minus
6I minus
plus
2O7 2 minus
then
plus 14H plus
okay, plus 14H plus okay, the 6E and
arrow
okay, arrow
3I2 plus 2Cr3 plus
yes,
and then plus 7H2O.
that's all. Well done, You see? So this is the overall ionic equation. They'll also ask you sometimes. Okay. And then what is my observation? Okay, let's go for my observation. All right. Okay. Copy first, All right. Can I clear my drawing? Okay. Clear? Now observation, As I told you that this was previous lesson. What happened to dichromate 6? It's orange, it will become green. Okay, so I'll put down first. All right, the dichromate 6 ion. Okay, observation number 1. Dichromate 6 ion. It's orange color solution. Dichromate 6 ion. Potassium, don't bother. Roman numeral 6 ion. Or dichromate 6 solution is okay. Will change color from orange to green. will change color from orange to green. How you know when you do it? You have to see at the surface here. Sometimes you have to warm it, you have to warm this test tube, then you can see it faster. Okay, it will change color from orange to green. You can see at the surface here. Okay, second observation, that one no problem. Okay, the iodide ion, okay, will change color from colorless to brown because it's becoming iodine. You see, it will change color from colorless to brown. Okay, settle that? Okay, and then oxidizing agent, no problem. Oxidizing agent, you just say dichromate 6 ion. Dichromate 6 ion.
Yeah. Check
Yes?
that right? Chromate 6 ion.
No, chromate wrong. Must be dichromate. Chromate is CrO4, cannot. Dichromate 6 ion. Must be dichromate 6 ion. Okay, chromate is another compound, another ion, so be very careful. Dichromate 6 ion. And the 6 must be there. Chromate also is 6 ion, but you must be careful. Dichromate because it's orange in color. Chromate will be yellow, yellow solution. Okay, dichromate 6 ion. All right. It's oxidizing agent. Reducing agent is just say iodide ion. Okay, so you can see, we have 3 oxidizing, 3 reducing. I gave you just now, you see the first part of the lesson. They can just take this and this, or any one oxidizing and one reducing. The reducing, sorry, is I minus, Fe2 plus. So now we're going to do one more involving Fe2 plus now. Okay, all the while iodide. Okay, so now we are going to do, okay, this one also done. All right. Okay, we're going to do this now. So I told you what, it can be either Fe2 plus, reducing agent, or I minus, or Br minus, one of them. And we add any of the 3 oxidizing agent. Can be bromine, water, or dichromate 6 ion, or potassium manganate 7. Okay, so now, okay, do the same thing. First thing I told you, what you were supposed to do, identify the oxidizing agent. So put here OA, put color purple. Although it doesn't look purple here, I'm just putting like a template. All right. Iron 2. Okay, highlight the iron 2. That is my reducing agent, not the sulfate. Highlight the iron 2. Okay, and what color is iron 2? Pale green, light greenish yellow. Okay. So this one is purple, not orange, purple, because manganate 7. Okay, oxidizing agent, reducing agent. Okay, done, All right. Okay, let me clear first. Okay, acidified potassium manganate 7 functions as oxidizing agent. So what will it oxidize? Okay, who wants to try? What will it oxidize? Alfred, want to try? Put in word for me. Acidified potassium manganate 7 solution, the purple. It will oxidize what? Alfred? Alfred, try? Or Jishwen? Jishwen?
Yes.
Can you give me the answer for B?
B.
B.
Oxidizes iron sulfate solution.
Oh, no, cannot. It's only the iron 2 is going to be oxidized to iron 3. So you must put it. Not the sulfate. Sulfate doesn't play a role.
Okay.
Try again.
Oxidizes iron 2.
Iron 2 ions.
Ions.
To become what?
To become iron.
No. Try again. Iron 2. Oxidation means plus 2 becoming what? Plus 3, isn't it? Correct, isn't it? So you should
yeah.
So it oxidizes what? Iron 2 ions to become what?
Iron 3.
Iron 3 ions.
Ions.
Because in the larutan, in the solution, we have ions. So be very careful. Right? The sulfate doesn't play a role. It will oxidize iron 2 ions to become iron 3 ions.
Okay.
At the same time, iron 2 ions is reducing agent, isn't it? So the word will be reduces or will reduce. Okay, you see the word? Okay, so that's not what we wrote. Okay, manganate 7 ions will reduce manganate, write in word, manganate Roman numeral 7 ions to become Mn2 plus, or so you use the word manganese, 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 put Roman numerals 2 ion. So manganese got +2, got +4, got +5 also. So you must mention the oxidation number. Manganese 2. I repeat again, acidified potassium manganate 7 solution oxidizes. Iron 2 ions will reduce manganate 7 ion. You see the word manganate 7 ion to become Mn2 plus or manganese 2 ion. ManGaNeS. I put Roman numerals 2 ion. Okay. All right. Now we try now. Be clear first. All right. We go for half equation oxidation. No problem. Okay. Half equation here. All right. Fe2 plus becoming Fe3 plus. Correct, right? Okay. Fe2 plus, arrow, Fe3 plus. That one, no problem. Okay. Complete for me. So this one is plus E, yeah? This is oxidation, correct? Okay, plus 2 to plus 3. This one, just now, the same one. Now try to memorize it. MnO4 minus plus 8H plus. Okay, plus 5E. I told you, isn't it? They will ask this, I'm telling you, very popular question. Mn2 plus 4H2O. Is that correct? Mn2 plus 4H2O. Okay, now give me the overall. Here, lower one is 5E. Upper one is E. So you multiply all by 5. Correct, right? Okay, 5 here, the upper part. 5 here, 5 here, 5 here. Okay, now give me the final answer. Okay. Alfred, try. Alfred? Are you there, Alfred? Quiet, no. Okay. Who else? All right. Always the same person asking. Okay. Chai Jisen, want to try, no? Chai Jisen? Quiet also. Want to try, Chai Jisen? Okay, give me the answer.
Fe2 plus
Okay.
MnO4 minus.
I've already multiplied by 5 already. What?
Oh,
Remember?
5Fe2 plus.
Okay. Try again.
5Fe2 plus
5Fe2
plus MnO4 minus
okay.
plus 8H plus
Okay, 8H plus arrow
5Fe3 plus
5Fe3
plus Mn2 plus
correct,
plus 4H2O.
well done. See? Not a problem. Okay. Then let's go for the observation. Okay. Observation. Okay. Can we try? Okay, we write down first. Okay. Just give a few minutes to write the overall first. Okay. All right. Okay, so what's the first observation here? I told you, isn't it? All right. You can even say, okay, manganate 7 ion changes color from purple to color. Write down first. That one I'll show you the video. But I think next Wednesday, I'm seeing you all in the school already. Okay. I don't know how is the chemistry lesson where when we go to school, we'll know the timetable, is it? All right. But anyway, okay, just write down. Okay, manganate 7 solution changes color from purple to colorless. Okay, and then first one, you can see that when it comes in contact here, it will change color immediately, become decolorized. Okay, then iron 2 ions changes color from pale green to brown. Fe3 plus is brown. Okay, oxidizing agent is, you can write that down. Okay, manganate 7 ions. All right, manganate Roman numeral 7 ions. Reducing agent iron 2 ions. So, habis cerita. Understand? This is the only thing you have to know. They won't go anything beyond this. Okay, all right. This one done. So, okay, this one you do for homework. Okay, that's why I use dichromate potassium manganate 7. This one you are going to use potassium dichromate 6 and iron 2. So oxidizing agent, reducing agent. So this one, the other half equation. Can you memorize it and tell me now? Jain, give me the answer for dichromate 6. What is the half equation when dichromate 6 becomes reduced? Without looking.
Cr2O7 2 minus
Okay, Cr2O7 2 minus
plus 14H plus
14H plus
plus 6E
6E arrow
2Cr3 plus 7H2O.
plus 7H2. Okay. MnO4 minus, give me.
MnO4 minus plus 8H plus 5E arrow Mn2 plus 4H2O.
Awesome. Okay, well done. Huh? All right. Okay. All right. So with that, it's almost 3 p.m. already. You can try the others. Huh? Just one more only. Okay. Any questions for today? In fact, you two. You try it for one. Okay. One is I'm using iron 2 with this, and then dichromate 6 with bromide ion. Kalau bromide ion, it will become bromine. This is also colorless. Colorless, bromide ion is a reducing agent. That's why I highlight that. Okay, this one is your dichromate 6 solution, is your oxidizing agent. It's the same thing. Okay, everything the same, only thing, the half equation you change a bit and then write overall. Okay, color change, please note it down. Dichromate 6 means you'll change color at the surface here from orange to green. And here, bromide ion here will change color from colorless to bromine is brown, to brown. Okay, all right. Any questions for today? All right, so we have done this one, and then we got 2 more types of redox reaction coming. That will be the next lessons. Okay, any questions for today? Anyone? All right, I think it's quite straightforward. Okay, you can check back and see. All right, anything you can just WhatsApp me. Okay, so we'll call it a day today. Okay, thank you very much. Okay, take care.